Welcome everyone. In one of our previous tutorial, we discussed about supervised machine learning where we learned about regression and classification. So basically in simple terms, classification is a type of pattern recognition where algorithms are applied to training data to identify comparable patterns in new data sets. Now depending upon the data set, there are many different classification techniques that we can use. Some of the well-known classification techniques are listed on the screen, where first is logistic regression, second is support vector machines, third is decision tree, and in the last there is naive Bayes classifier. So let's jump to the very first topic and let's discuss what is logistic regression. Now logistic regression is a well-known machine learning algorithm that comes under the category of supervised learning. Now in this, independent variable are utilized to predict the category of dependent variable. For example, the output of the logistic regression can either be yes or no, 0 or 1, true or false. In this way, all the outputs are there in logistic regression, but rather than providing an exact value between 0 and 1, the model provides a probabilistic value. Now both logistic regression as well as linear regression are quite similar with slight exceptions. While logistic regression is utilized to solve classification problems, linear regression on the other hand is utilized to solve regression problems. So in logistic regression, we fit an S-shaped logistic function which predicts two maximum values rather than a regression line. Now in this technique, we utilize a logistic function which is also the basics of the term logistic regression. Additionally, this logistic function is also represented by sigmoid function, and the value of this function ranges from 0 to 1. Now to understand the working of logistic regression, we need to understand the working of sigmoid function. So a sigmoid function is a mathematical tool utilized to convert the projected value into probabilities. It simply transforms any real value between 0 and 1 into another value. Moreover, the overall result of logistic regression must fall within the range of 0 and 1. Additionally, we also apply threshold value in logistic regression. The key role of using this threshold value is to predict the likelihood of either 0 or 1. Now, if we discuss the types of logistic regression is classified into three main categories. First is binomial. So, in this logistic regression, the dependent variable can only be of one of the potential types such as 0, 1, pass, fail, male or female. So in this there are only two dependent outcomes. Then the second category of logistic regression is multinomial. In this, the dependent variable may be one of the three or more unordered kinds. For example, categorizing images into dog, cat or sheep. So this type of example comes under multinomial. And in the last we have ordinal. So ordinal is also similar to multinomial. The only difference between multinomial and ordinal is that multinomial consists unordered categories, whereas ordinal consists ordered categories. For example, if I want to categorize temperature, I can categorize it into low, medium or high. So I hope with this you understand the main working of logistic regression. Let's move forward and let's discuss about naive Bayes classifier. So naive Bayes is a supervised machine learning algorithm that is utilized to solve classification problem, and it is a probabilistic algorithm where outcomes are predicted based upon probability. Moreover, this algorithm aids in developing quick machine learning models with capability of making accurate predictions. So if I talk about examples, spam filtration, sentiment analysis and text classification are some well-known examples of naive Bayes algorithm. Now the name of this algorithm, naive Bayes, is derived from two words. First is naive and second one is Bayes. So let's discuss these terms. So if I talk about naive, this method makes assumption that the existence of one feature is unrelated, or we can say independent of the occurrence of other feature. For instance, we want to recognize fruit based upon its color, shape and flavor. So a red spherical sweet fruit will be recognized as an apple. Therefore, without relying on another, each feature works independently to help us recognize it is an apple. Now the next term is Bayes, and this term is basically utilized because the naive Bayes classifier is based on Bayes theorem. So here Bayes is representing Bayes theorem. So to understand the overall working of naive Bayes, we need to understand what is Bayes theorem as well. So let's discuss that. In Bayes theorem, conditional probability is very important term, so let's understand that. So conditional probability plays an important role in understanding the Bayes theorem. The conditional probability of x given y is the probability that even x will occur provided event Y has already occurred. Now if I talk about Bayes theorem, it is a mathematical formula of calculating conditional probability in statistics. In simple words, it is used to find how likely an event is associated on proximity to another. Moreover, this theorem is also known as Bayes law, and it is even recognized as Bayes rule. Now on the screen you can see the formula of Bayes theorem. So in this formula, PAB represents the conditional probability of event A occurring under the assumption that B is true. After this, there is PBA, which represents the conditional probability that the event B will occur assuming that A is true. And after that we have PA and PB separately, which represents the probability that A and B will occur separately from one another. Now imagine a scenario where there are several inputs, for example inputs from x1 to xn. So with the help of Naive-Bayes equation we can predict the result y, and this is the overall formula. Here nothing major has happened, just we are taking in the previous equation we were only talking about single input variable, but now here for this equation we are talking about multiple input variables. Now if I talk about the categories of Naive-Bayes, it is also categorized into three main categories. So very first is Gaussian. This Naive-Bayes model is generally employed in classification and it relies on the premise that feature data is distributed normally. After this there is also multinomial Naive-Bayes. So generally discrete counts are handled by this model. So if I take an issue of text classification as an example, we can take Bernoulli trial into consideration here, which is the one step further. So instead of counting the number of words appearing in a document, we have to count how many times a word appear in a document. And in the same way there is Bernoulli as well. So if a feature vector are binary in nature, we can utilize Bernoulli model. So one use of this is text classification using bag of word model, where ones and zeros represent the words that occur in the document, where 1 represents the words occur in the document and 0 represents the word that does not occur. So I hope with this you got an overview of Naive-Bayes algorithm. Let's move forward and let's discuss about decision tree. So in a nutshell, decision tree algorithm is nothing more than a simple if-else clause which is applied on data to predict some result. So in a nutshell, a decision tree algorithm is nothing more than a simple if-else clause which is applied on data to predict some result. Now we have already discussed about decision tree in our previous tutorial where we discussed about decision tree regression. So we basically know that a decision tree algorithm is categorized into two types. The decision tree classifier, which is also known as classification tree, and there is another type which is decision tree regression, which is also known as regression tree. Now we have already discuss how decision tree works in our previous tutorial. So here we will focus on understanding the decision tree classifier. So this classification tree algorithm includes the use of fixed and categorical target variables, and the main step of this machine learning model is to determine the class that the target variable would most likely belongs to. So let us understand this thing with the help of an example. So on the screen you can see the decision tree. So for instance, we want to determine whether a user will buy a car model based upon multiple features like car color, car mileage, or car model. So if you look closely to this decision tree, first it is checking whether the car have a color black or not. If the car have a black color, then it will check the model of the car. After this it is checking the mileage, and based upon that it is making the decision whether to buy the car or not. In the same way, there is another branch where we are checking another color of car and making decision based upon that. So just like classification tree, the regression tree is also utilized to forecast value of the target variable. However, instead of discrete values, the regression tree tries to predict continuous values. So now we understand both of the types. So let us understand some of the differences between them. So whenever we need to divide the dataset into group that corresponds to the response variable, classification tree are utilized. The classes often provide options such as no, yes, true or false, 0 or 1. Moreover, in classification, the variation approach utilized when there are more than two classes in particular situation. However, when the response variable is continuous, regression tree are utilized. For instance, a regression tree is employed when the response variable is anything like the cost of a piece of a property or day's temperature, etc. So I hope with this you got a brief overview of decision tree and decision tree classifier. And let's discuss about support vector machines. Now support vector machines are one of the well-known supervised machine learning algorithm, and this algorithm can be utilized to solve both classification as well as regression problem. However, it is largely employed to solve machine learning issues. Support vector machine algorithm, which is also commonly known as SVM, establishes the best line, or we can say the decision boundary, that can divide n-dimensional space into classes, allowing us to quickly classify fresh data points in the future. And in this we utilize the concept of hyperplane, which is the name given to the optimal decision boundary. Now we have already discussed how SVM works when we discuss about support vector regression in our previous tutorial. So in this video we will focus on some of the key differences between SVM and SVR. So support vector machine, which is also known as SVM, is the classification algorithm. Now, in order to accomplish classification, we utilize classifier to forecast discrete categorical labels, while in support vector regression, which is commonly known as SVR, is a type of regressor. Moreover, regressors carry out regression in predicting ordered continuous values. Now both the model predict various type of variables, very similar technically. So with this we have come to the end of this tutorial session, where we have discussed about some of the common types of classification algorithm. Thank you so much for watching. We will see you in the next one.